Hello, hello. Hello, everyone. Can you hear me? Okay. So, as usually, I hope you had a good day.
Yes.
I hope you had a good day. Okay. So, as usual, we will do the tech talk tonight. I just repeat the idea is sharing your experience in order to improve all the team all together, in order to be better all together for the next years. But first, we will have on stage someone to share his experience. And we just spoke a few minutes ago and said what it is very important is to deliver something. And basically what they have achieved so far is beautiful. Please, can we have on stage Stewart Wilkinson from Aviva Yacht?
Hi, everyone. Yeah, I'm the founder and chairman of Vita Yachts and an Aqua superpower. So we're sort of doing two things, and I'll talk to you about that in a minute. I wanted to put this slide up first. In fact, it's my only slide. So, what it shows is the average journeys taken. This is from sort of data points taken off boats, all around the Mediterranean. What you can see, and the point I want to make today, is that almost all boating is coastal. If you see around where the data prints are, not only is it coastal, but for day cruising, which is the market we're trying to electrify, it is very short. So what I wanted to ask everyone is, what does everyone think the average day trip is on a boat? How far?
70 kilometers.
Okay. 50 nautical miles. Okay. So what we're trying to do, and what's key to this market is you've got to build the infrastructure first, like Tesla did. Why is Tesla moving ahead of other electric vehicles? Because it has the infrastructure, the supercharging network. It's key with a boat. Even though you're going to go 50 nautical miles, what are you going to do then? You're going to want to come back. If you're a commercial operator, you're going to want to rent your boat to someone else. If you're a hotel, you want to bring some guests back. So all the people we talk to, that's the key thing. It's like, we want to go 50 nautical miles, so we don't need to go that far on this electric boat. But when we get there, we want to charge fast and come back, or go on. So what we're trying to do with Aqua is build a global network. And that sounds like a massive challenge, and it is, and it nearly kills us. But what it means is that it's easier to do in boats than with cars, because boats, as we all know, only operate in certain places. And so you can dominate that area with chargers and then make each area viable for electric voting. So that's a message I wanted to give today, is that many, many, many more boat journeys can be electrified than people will have everyone believe. And the key challenge is what you do when you get there. You need to charge fast. So the key challenge, as it is with cars, is the charging experience, charging quickly when you get there. Once we've done that, then what we can do is, and this is what we're doing here on the Mediterranean. So some of these pictures are, well, from all around the world. This is a cool moment. This is the first fast charger for boats in the US on Lake Tahoe. This is in Ventimiglia, and a lot of these are along the coast here. This is our test bed. So we're going from Ventimiglia to Saint-Tropez, and us and other guys with electric boats are using these chargers to move up and down. You'll see out the window, those you can see, that's the Vita Lion moving out there. Now, that boat has been back and forwards to Saint-Tropez, as has Exshore behind it a lot of times, on our chargers. So the inspiration here, I guess, is like, it's happening now. It's not something that's going to happen tomorrow. All boats can be electrified now. So the thing that keeps me up at night and gets me frustrated is that every time I see a boat, I'm like, it should be electric, because they all can be. And if it's not electric, if it needs to go farther, it needs to have hydrogen fuel cells on it. But the technology is here, you know, and that's key. I was talking to Jeremy earlier. This is a cool thing that hopefully we can do. If we can get hydrogen generation for the electricity in the chargers, that would be a super cool thing to do. So that'll allow us to go to places where electricity isn't so prevalent. So one other thing to say, how many electric boats, how many boats are out there? How many day boats are out there, does everyone think? 30 million, okay? Below 10 meters. Now, some of those below 6 meters are going to be too small for our domain, but the challenge for all of you guys here, and it's brilliant to see what you're doing. It's amazing, this event, and it's going from strength to strength every year. We've been here, I think, for 6 years now, or 5 years, 5 or 6 years. And every year I see it getting bigger and more students here. It's fantastic to see. But the mission is really happening now. So go for it. Technology's there. Technology can get better. We can improve the range. We can improve the charging time. But it's already there. And the faster we can move, the better. So let's do it. Thanks for listening. Have a good tech talk.
Thank you so much and congratulations for what you achieved so far. I really like people that do things. So you know the rules. We will have tonight 10 tech talks. So each team has to respect the schedule. 5 minutes. Yesterday we were a bit above the schedule. So the first team to join the stage will be an energy class. It's Capgemini Engineering. Please come on stage. And for the jury, they are not university. Bonjour. Merci. Tenez, et vous avez l'écran ici, si vous voulez, pour pas vous retourner.
Ok, super. So, hello everybody. We are the Capgemini engineering team from France. And it is the second participation for us, and we are very happy to be here for this event. So our team work in an internal research and innovation project called SOGREEN. And the objective for this project is to, our team is composed about trainees and some engineers with different skills, like electric, electronics, mechanicals, etc. And our objective is to make a solution for our customer. So for our bots is to the second participation, like I said. So we have made some changement. The first is the electric motor. We have now 15 kilowatt electric motors homemade. And we have some battery lithium-ion. And we have a Mux Lab, which is a solution, an innovative solution developed by Capgemini Engineering. And the objective of this solution is to optimize the energy management of the boat and of the different sources of energy, like solar panels, hydrogen fuel cells, and battery. So about our conception is made with the base of tubular aluminum chassis. Because the aluminium is, can be easy recyclable. And we have made some CFD thermal study for optimize the airflow for the hydrogen fuel cells. So thanks to a partnership with MathWorks, we have modeling system with the Simscape suite. And we have made a CFD for thermal, hydrodynamic, and aerodynamic characterization and use result in the Simscape models. We have made a digital twin. The objective to this digital twin is to keep the fuel cell in a high efficiency range with a high level of monitoring of system operating data. So about the material is the same that the last years, but we have a changement about the electric motor because it is an electric motor homemade. We have a hydrogen fuel cell like the last years, and we have more lithium-ion battery. The new is a MUXLab computer because it is connected with to a customized human machine interface and to a Raspberry. The frame is made to tubular aluminum for the eco-conception, and we have covered our boat with for protect against water splashes. We have some problem with the teleworking, which is difficult to work together in the same time. And we have a lot of problem about the long delivery time for materials. Last year, our budget for the eco-conception of our boat is about 50,000 euros, and this year we have invest 20,000 euros for improvement of this boat. So we have made some tests at Vitral, and the data collected by the system is stored on server in the real time. So the MUXLab make it easy to deploy complex hybridation algorithms thanks to the partnership with MathWorks. And we have a good thermal management and ergonomic cockpit separate from energy storage. We have made details on the life cycle assessment. So the difference between the last year, there are no very difference because we have the same. And the changement was very about the battery lithium-ion because we have some battery, more than the last year. So the main impact observed concern mineral extraction essentially. But there are also some impact about other environmental indicators. So like I said, we have eco-conception and we use aluminium because aluminium can be recycled, and the tarpaulin is made of fully recyclable materials. And to finish, the digital twin that we use, the benefits are to see the catamaran in real time. To answer, it is providing high gas performance, and we can see the energy in real time to make sure that we maximize the renewable energy use and reduce the CO2 emission. So one of our objectives is to develop a hydrogen propulsion chain in order to have a solution to offer our customers looking for technology to support the energy transition. Thank you for your attention.
Thank you so much.
No. Pardon.
Allô, allô. Allô? Right. Thank you so much. Do we have a question in the room?
Ça marche pas.
Please. Merci beaucoup. Simplement, what is interesting with your, what looks to be interesting with your digital twin application is maybe the comparison that a lot of teams cannot do between, you know, producing something in real life and producing at the same time something on your digital twin, and maybe compare how simulation, you know, what are the results you get from simulation, what are the results you get from testing. So did you have those times where you actually put both, let's say, in parallel and try to compare the data that you get, some things that you get from one, some things that you get from the other?
Not for the moment. We hope to have that after the race, and to storage the data, and after we can make an optimization or to compare with our model and the reality.
Could you explain better what means HMA, the system that you use for human-machine intelligence?
Not really. Yeah, it's the HEM. Yes, it's a screen that the pilot can see, and we have some information about the boat, like the speed, the percentage of the battery that we can use, and the capability of the hydrogen fuel cell.
Do we have another question? I guess I have one, because you go through your slide, and inside the slide there was written something like you had a frog design. Yeah. That's one of the names of my best friend, so I want to have a bit more details about it, please.
It's a design created by a part of our company, because we have a specialization on this design, and the objective is to optimize the design of the boat with different aspects.
In question of weight, price, time of production, what are the aspects that you can consider in this process?
I don't know the details. Sorry about that.
No, thank you. It looks efficient anyway. Congratulations.
Thank you.
Merci. Ils sont pas sympas d'avoir laissé toutes seules. Ils sont pas sympas d'avoir laissé toutes seules. So, can we have please the second team on stage? It's a solar class. It's a Sunflare solar team. Can you please come on stage?
Thank you.
This, you have the screen here.
Okay. Good afternoon, everybody. My name is Arjen Abma, and I'm part of the Sunflare Solar team. We are at this event for, I think right now, for 5 or 4 years. We did this presentation a few times. Also, on the beginning, it was a different template, and then we had all the other years the same template. So we chose to do it a little bit different than the template that is passed by the event. So what is important is that one of our missions is to inspire the new generation with the techniques and also the sustainability. And also that's why we chose to take another template, our own template, because we think that this will inspire you guys the most. So we are based in the north of the Netherlands. The Netherlands has a population of 17 million people, 17.1 to be precise, and 26% of the land is below the sea level. So in the Netherlands, it is also a reason to think about sustainability, is because it's a danger for our houses. So almost the whole team lives in the north, and if the dams or the dijken, how we call them, break down, our houses are going to be underwater. And it also happened in the past. So almost, I think 60 years ago, one of the dikes broke and a lot of people died there. So it's really serious for us all to think about sustainability. And because we have a lot of water, that's also the reason why also the Netherlands is a fun country to work with the Solarboat. So if we look to the team, so we started in 2014. So it started with our first school where we guys met. Then we started to do a university with a private team, so not with the university. So it was a foundation that we started to be able to make our own choices, to say, okay, we get money from our sponsors, and we want to decide where we invest the money in what techniques and what route that we are going to choose with the team. So we are working for 8 years now, and we are, I think, work around 5 or 10 hours a week, each person in the team. So and we are with 10 persons here. So for the past 8 years, we invested a lot of time next to our works that we have right now. So if we look to our techniques, and I'm going to keep that a little bit short because in general for a lot of teams here, the techniques are quite, or let us say, standard. So we have our solar panels, 1500 watt peak. We built them, or we soldered them ourselves with another team. So we purchased the cells, we searched companies to help us with, and we built them there ourselves. So that's pretty interesting to do. Also the carbon fiber, we build everything in-house. So all the hulls that we make, we build that in-house, and all the carbon work is made there. So all our struts or hydrofoils and so on, yeah, we do it. Also the mechanic part, we design them all by ourselves, and we search partners to make them for us. So also on the electricity, we designed maximum power point trackers, which are electronics for the solar panels, which we also design ourselves. So over the 8 years, on the beginning, we purchased everything from external companies. And over the years, we set every year, okay, we set a new goal with each other for what we want to do next. And that's pretty interesting what time can do. If you have one team, which expands a little bit, but the core of the team is still the same over that 8 year. So the big question right now is, do we ever break something down? Yes, we do, and we did it a lot. So if you look to the Veolia or Sunflare solar team with big Veolia on it, underwater, it looks like there's hydrofoiling and it looks quite smooth and fine. But in the back end, when we are together, we break down a lot. So these pictures here are only from this year, what we have broke down. So if we let me think. Next slide. So, if we look to what we broke down and we learned from it, we had a set of three points there. So we want to focus on how do we keep our boats sailing when something breaks down? Because if something maybe has a small error, we have it. If you look to your electronic cars, it also has maybe some errors sometimes. A small software update and it's ready. So the first point that we have is that one function module should not rely on the other. So then the second point is reduce the failure points for each function module. And the third one is when developing new features, try to break it down in steps and only develop features once at a time. And that's also in line with the 8 years that we had to improve over the time. So the first example is what you can see here is that our battery is a 48-volt system, and a lot of teams have like converters in there, so they convert the 48 volt to 24, and then they have like their safety system on it or something. And that's also what we see on the left side. So you see the converter in there. So the problem here is that everything comes on that small converter. But why should you implement a component which can break down easily, which influences your whole boat? It can be the reason that you do not finish your race. So what we do is that we purchased everything on the 48 volt. So we have no converters in the unit, and everything is based on that 48 volt. So that's the first point. So the second point was to reduce the failure points. So in the boat, there is a lot of data, and everybody has like a bus in there which handles the communication, and we are using CAN bus for this. So what we see here on our left side is that we have on the rear, we have our hydrofoil, and we are doing that mechanically, also our electrical. So we have the potential meter there, and we can steer it a little bit. So what people do is that you implement like a module there, which communicates by CAN bus to another module on another part in your boat. So, and that's wrong, because if there is like a small error on your CAN bus system, it influences your system, and it can lead to that you cannot fly anymore and do not win the race. So if you look on the right upper side, is that what we did is that we have the analog control module directly to the servo drive, or to the servo, which we can use on the to control the hydrofoil. And then the servo controller is read out by a CAN bus, and this is what we use. So when the CAN bus breaks down, it does not influence the way of sailing for us. So, and then the last point is that we are flying mechanically. So you have a bunch of options for it. You can do it electrical with sensoring, and we are doing it mechanically, but we have the goal to do it electronical with sensors in a time. But we do it mechanically because we want to have that stable, because if you have too many unknown points in working on new techniques, you don't know what you're testing and what is the result of that we're testing on the water. Because if you're not stable mechanically, how can you do proper sensoring and proper PID controlling of that information? So our main focus is focusing on having it stable, continuing doing it electronical, and also right now we are going to also get some data which we can use for the algorithm that we need. So because of the time, I will skip the summary. So our boat is almost all the time open, and we do it with a reason. We want to invite everybody to walk by, ask us questions. If it is closed, please let us open it for you, because we want to inform everybody about what we do and how we do it. So I think everything as a summary is that break things down and be inspired by it. So thank you for your time.
Thank you. Do we have questions?
Another way to reduce failure points is redundancy. Do you have that in your boat? So two components that can be in parallel, so that if one breaks, the other one can be used. Do you have that in your boat? Or if not, what do you think of it?
We are not doing it right now, so there is no redundancy in the unit. So yeah, that's it. But how I think about it is that it adds, in a mechanical way, adds weight, and in a electronical way, I don't know the information on that one.
And can you share with us the weight of your boat?
Yeah, the weight of the boat is 91 kilograms, so we can lift it with the 3 or with the 4 of us. So we try to build it as light as possible. And we're busy with a new hull, which is 10 kilograms lighter than we have right now. So we have some interesting new techniques for that. Maybe next year.
And are you using Nomex on the construction of your boat?
No, we're using foam right now.
Okay, do we have another question? I guess it's clear. Thank you, and thank you for opening your boat. I hope that many other team gonna have a look at it. Thank you.
Okay. Thank you guys for your time.
So now the third team on the stage, it's still a solar team. It's an Antwerpen solar boat team. Sorry for my pronunciation. Could you please come on stage? It's Antwerpen normally, no?
Yeah, Antwerpen.
Sorry, it was written the other way. So. This, you have the screen, 5 minutes.
Good luck here. Thank you. Hello everyone, I'm Seppe and I will present the tech talk for the University of Antwerp Solar Boat team. We're a team based in Belgium, near the city of Antwerp, which is, our faculty is just outside of the city. And we have also the Port of Antwerp, which is the third largest port of Europe. Our team exists of 9 members, 3 master students and 6 bachelor students. We work on the boat during our engineering courses, so it's all free time that we spend on it. Our new boat we brought here was designed in 2019, but due to COVID, it's the first time we're here with it. It's a completely new hull shape that's optimized for waves, so it cuts right through it. It's also way lighter than our previous hull. It's 25 kilograms lighter, and it goes also 3 kilometers per hour faster. We also designed a new steering system, but we don't have it right now because of problems with our suppliers. Our methods and design are pretty straightforward. We make a CAD model, and then we do a CFD analysis on it to see how it would work in real life, and eventually we will test if it is the same as our simulations. In these simulations, we look at things like wave patterns, shear stress, hull pressure, and of course, we can make cool renders out of it. Our new steering system was meant to be a hydraulic steering system, replacing our cable system because we had a lot of issues with it, with cables stretching and coming loose. We try to make everything in-house, so our hull is made by vacuum bagging a carbon fiber composite made of a layer of carbon fiber, PVC foam, and another layer of carbon fiber. When this is finished, we can take the mold, the boat out of the mold and trim the edges and finish it up. Eventually, we made also a deck with the same carbon fiber composites, which is removable, so we can work on the boat, on the whole boat, everywhere. Our driveline is also completely designed by ourselves. It's aluminium, special aerospace grade, so it can withstand salty seas and doesn't corrode very much. We have straight cut gears. This increases efficiency by 2%. It's a 2-to-1 ratio, so that means the 6,000 RPM motor reduces it down to 3,000 RPMs. We have loads of different propellers which we produce in-house, each for different competitions like a sprint or endurance, so we're always at the maximum efficiency point. our solar panels are from Sunbeam. These are right at the maximum capacity of what's allowed, maximum area. So we have 14,440 watt peak. And these are way more efficient than our previous one with a solar efficiency of 24% instead of 16%. We use a standard battery pack like everyone else with 1.5 kilowatt hours, and it's 50.4 volts. All this whole process and building the boat, it takes about 7 months, but because we have also our engineering courses, it takes almost 2 years, but the time we spent on it is about 7 months, and it costs around 15,000 euros to build a new boat, thanks to many sponsors who help us out, of course. When we go testing, we do about 6 test runs to check if our hull is correct. And then we do a drag test, so you see the scale on the right, which is just a scale. If you pull the boat behind it, it will read how much Newton you're pulling. And then we can compare that to our simulations. We also do stability tests. We check at different RPMs if it's also the same power you need to propel the boat, and also with different propellers if that's also the same. And then we do a trial like you would do here with a slalom test and a sprint test. For our life cycle assessment, we try to keep everything modular. So we have an old boat and our complete battery pack, electronic pack, wiring loom, drive frame is all swappable between them. So we don't need to produce a new battery pack if we produce a new boat. And also our current battery pack is a reused battery pack from a solar car from another university, the KU Leuven, who won with the with the solar car in Australia a few years ago. And currently we are looking at flex fiber and high bio content epoxy resin. This is so we can reduce the carbon footprint of the protection of the boat, because of course while we're sailing it's not polluting the air, but the production is still very CO2 heavy due to the composite materials. And our main innovation feature, our boat is also a research boat since this year. We have a research deck we can put on the front of the boat, remove the solar panels, and other faculties from our university can put their research equipment on it, like to inspect maritime growth on docks or do water quality tests, so it's a multifunctional boat. Where we see solar boats in the future is mostly on things like taxi boats, on urban waterways, and to transport people, because that's the most efficient way, because solar power is not the most powerful, but it's free, so that's why. And eventually we would like to thank all our sponsors who make it possible to come here. Are there any questions?
Un, deux, un, deux. Beautiful. Do we have some question? Yes, from the jury, I guess you will have plenty of questions.
I don't want you to take too much time to respond, but could you give us some aspects, some details about your different propellers and the different usage that you have? You said you have different propellers depending on the competition and the use of the boat. Can you give us some detail onto where do you work for certain competition, so on and so forth?
I will take it, for example, our sprint propeller. It has a smaller diameter, which it will mean it has less torque at lower RPM, but it will be able to go faster, and it's also higher pitch. For example, we produce them by it's an open source program, OpenProp, and it just designs a prop, and then we get it all automatically imported to our CAD software, and we can modify it to our needs.
Good. I do have in fact 4 questions. The first one is on your hull. I understand, if you can please go back on the previous slide, that was a former boat compared to the new boat. Is it correct? I did not see any foil on the new boat. Is it Archimedean boat?
This boat doesn't have any foils. It's
Okay.
also not planned to put foils on this one because it's the way it's designed is not really handy to put them on there. But we're next year we will start designing a new boat which will have hydrofoils.
Okay. Why I am asking you this question, because if you can please go on the previous slide, if it is an Archimedean boat, most of the time we are looking to reduce the food number, and so for that we are trying to have the longest boat as possible. And from the design I just see here, the new boat looks shorter than the previous one. Is it correct?
Did I understand shorter?
Yes, it looked like the length is shorter than the previous one.
This one is 20 centimeters longer than our previous one. Our last one was 6 meters. This one is 6 meters 20 long.
Okay, then my image was give me wrong. And have you considered adding a foil, not order to fly, but maybe to increase the efficiency about your hull shape, like a hull vane or kind of foils on the transom of the boat in order to reduce the drag of the transom of the boat?
No, we have not researched that.
Okay. If some of you are considering having, let's say, not a flying boat, but Archimedean boat, I really invite you to have a look at it. And I'm also inviting some of the architecture for the standard boat, which are not all flying, but standard boat, just to have a look about what we can do with some hydrofoils in order to reduce the drag of the boat. On the previous student contest, we had some foils on the back. We were reducing the drag from an Archimedean boat in between 5 to 8%, which is a lot higher than having a foil that does not work. Then I understood that you made the design with the CFD. Have you worked with the CFD optimization software? And you could please then share this software with the others.
We used from Siemens Star CCM Plus.
Okay, and what kind of optimizer have you had on top?
Heats MDO.
Thank you. And that was my last question. Thank you. Then, could we please have on stage team number 4 of today? It's another solar team, Whisper Power Solar Team. Could you please come on stage? Did I pronounce it good? Whisper Power Solar Team, they are not here. It looked like if the team is not here, the penalty is huge. Okay. Time pass, so then you know what you have to do. I'm sorry for them. Then the team number 5 of today, it's Alpha College. Could you please come on stage? Yes. You swap. Sorry. This is a remote.
Yes.
I give it here.
Wonderful.
You have the screen here, and you have 5 minutes. Do your best. Good luck.
Thank you.
Sorry.
Doet hij het? Hallo? Doet hij het? Ja, hij doet het. Top. Do you remember when you were a little child? You had no idea what was happening in the future. And look at us now. We inspire and bring ideas together, and that is very important to do right now. I have to say, listen and look how we do it as young students. And why I'm saying young students, that's because we're from, excuse me. And why am I saying young students? That's because the chance is big that we're a young team here. We're from the secondary vocational education, so everyone is from around 80s, 90s years old. So we're a team from the Netherlands, and our school is the Alpha College. The Netherlands is a Western European country. It is located in the Benelux, and it is a country within the Kingdom of the Netherlands. We are a regional Christian MBO school in the north and east of the Netherlands, in Groningen, where it is possible to follow regular company training courses. We focus on 3 values: connection, trust, and entrepreneurship. Or both. It's powered by hydrogen. It's a PEM fuel cell intelligent energy 1200 watts through ACES LifeBow battery 80 volt Torqeedo 4 kilowatt motor.
Hello everyone, my name is Julian and I'm gonna tell you something more about our boat. Our boat is made of a part of components, but first we're gonna tell you more about this. On the picture you see a 3D design of our boat, made by the following students of our company. For this we used a program named Autodesk Inventor, but also we used Fusion 360 for making a 3D drawing. Here you have an electric diagram for use. We used A-Plan. Also at our school we use 3D components that we have a maker lab in our school. But we do ook laser cutting of plate metals, of sheet metals, sorry. The metals we use are aluminium, that's used for the firmness of the pilot chute. Okay. Also we use plexiglass to making for the cockpit. Also we use polyester for the making of the boat. Also we use carbon fiber on our energy is suspended by a carbon fiber frame. We had ook a little bit of problems. We have problems with the delivery for some of our parts of our boat. Also, we have one propeller on our boat. On the testing, we had one propeller on our boat. We got not too fast as 15 kilometers per hour. The time of the production we did is about 1 year. About the boat is making by our school. Here can you see a picture when we are testing.
Waar ben je gebleven?
Moet je doorgaan?
Waar ben je gebleven? Waar ben je gebleven? Waar ben je gebleven?
Ga je door? Moet ik gaan?
Ga maar door. Waar ben je gebleven?
Okay, here can you see a lot of results from our testing. We have a boat with a propeller of 1300 RPM. The max speed of our boat is 13 kilometers per hour. The total weight of our boat is about 130 kilograms. But we have not enough testing, but we have not enough time to test. Now I'm going to tell you something about our life story, life cyclus. The first time we have to deal with hydrogen and our stability of our lessons. We worked with, for the first year with RC cars. On our education we also have a group that deals with RC cars. And together we research into hydrogen. Also, Solar One challenged us to sail a different durability with students. The following. Now I'm going to tell you something about the Eco project. We only use materials and components for local businesses. We still on the taste of eco design of our boat.
Of course, we use hydrogen as our source of energy. We still have to make sure that we use the energy as efficient as possible. We can display our data from the boat to the bullet as well to the shore. We are still testing and searching for new innovations. This is our first time to join the Energy Boat Challenge in Monaco. But I hope that this is not the last time. Because it's very important to share and come together with our ideas about the future. So I have to say, stand or wake up before it's too late.
Bravo. Hello, hello. Thank you so much, and you can be proud because how old are you?
19.
And how old are you?
19 also.
19 also. I was not good as you at your age.
Thank you very much.
So, do we have some questions for them?
Well, first of all, I want to say it's really beautiful to see such young people already thinking about these things at such a young age. I really hope that there are a lot of 17-year-old people are looking right now and are thinking, oh, I want to ask that to my decaan. Ja, ik weet ook soms nooit het Engelse woord.
Geef niet
Sorry.
hoor.
So
Geef niet.
go to run to them and to ask if it is possible to start such a project on their school. I was just wondering, because I think you are still doing a lot of courses. How much time are you able to spend on this project?
On this boat?
Yeah?
1 year.
And then full time or partial?
How many hours per week do you spend on the...
Wow. Am I wrong?
Is it really like a hobby project, or is it also that you do some courses beside this? Or volg je nog steeds je colleges, zeg maar?
Ja.
Of ben je, ja,
Ja.
oké. Dus hoeveel
Ja,
tijd
sorry,
heb je nodig?
Ja.
Hoeveel tijd heb je dan om in het project te steken?
Every week, around 1 day, but sometimes, yeah.
It always gets more. Okay, thank you.
I am sorry, I need to respect the schedule, so unfortunately I cannot ask other questions, but I'm sure there is plenty of others, and for sure you will have our support, you have their support, and you have the support from everyone in Monaco, and for sure you will come back, and you will be always welcome. Thank you.
Thank you.
Thank you. So, can you? Yes, this one is working a lot better. Maybe can we highlight a bit this one? A bit high. On peut monter le son du deuxième micro. So I have to share with you something because I know that WishUpPower Solar team was not joining the Tech Talks, and I'm sorry to say that if they are not at the Tech Talks, they are disqualified of the competition, so they cannot race tomorrow. So now the 6 teams that have to participate in the event, it's another solar class team. It's BME Solar Boat team. So can you please join the team? Join the desk, sorry. BME Solar team. Yeah, but after the talk, it was too late. So the screen, you have the screen here, 5 minutes, do your best, good luck.
Okay, thank you very much.
Excuse me, can we please have, thank you.
So, hello, we are from the BMS Solar Boat team from Hungary. And Hungary is quite a little known country, I think. It's located in the Eastern Central Europe. What is, I think, quite important is that it's landlocked, so we don't have any seas and not a huge boat culture here. So this team is quite unique in our country, and we are a university team from the Budapest University of Technology and Economics. And all the team members are university students, mostly engineers, but also financial studies can be are necessary for this team, and we do it in this. We do this project in our spare times, besides university, without university supervision, mostly.
So to talk about a little bit about our team, as you can see, we've got lots of fields from, for example, we've got a separate mechanical group. This group is only responsible for the hull, for the maintenance of our boat, and for the propulsion system. We've got our own financial group. They are mostly responsible for our PR management, marketing, keep the contact with our sponsors, and keep the updates on our social media. And finally, we've got the electrical group.
And we are mostly responsible, of course, for the solar panels. That's a solar boat, so it's quite necessary. And also for the electrical propulsion system and controls and telemetry.
Yeah, so a few things about our boat. It's made completely out of carbon fiber, to be precise, from prepreg and aramid honeycomb, except our deck. Our deck's material is glass fiber with aluminum honeycomb, so it's a little bit on the heavy side, to be honest. But besides it, we have a 3 hydrofoil design. Currently, this is not done fully yet because it's still under construction. But to talk about a little bit about the electrical side.
Yes, about the electrical side of the things, we are using monocrystalline Solbian solar panels. The usual around 6 square meters of them, and Torkstar BLDC motor. And we use LTE for real-time monitoring and telemetry, so that we can actually view the status of the boat in real time from the shore and don't have to nag the pilot over radio to read in some data.
So this year we had some new projects. First of all, we have our new propeller, which is designed with a generative design. It's like we had an initial model that we started with. Then we parameterized it up, given every aspect of the geometry. Then we have made a simulation out of it in CFD. Then we made some response surface calculation for it and then optimized it. And we repeated this circle until we get the required result that we wanted to get. And this way we have different propellers as well for different races. For example, we have a different one for the sprint and different one for the endurance as well.
Yes, on the electrical side, our boat, unlike most of the other ones, doesn't yet have any CAN-based communication system on board or anything like that, and we really want to change that this year. mostly because of the structure it gives, and I think that structure can really ease development for new functions. The main focus of this project is this universal control board seen there. It has an RP2040 Raspberry MCU, which is not the most optimal solution, but it can be sourced like most other microcontrollers, and it has various functions for stability and for the universality. It can display error codes, can be configured with some small switches, and it can also perform logging functions.
So to talk about a little bit again of the hull itself, as I said earlier, it's made out of carbon fiber, and for us the complete construction of our boat took around 2 years. It was completely made by us, mostly in-house, but we got some help from our sponsors as well. For example, workshop places, or they even helped us to manufacture the mold for the boat itself too. Besides, we've used lots of materials. For example, we've used aluminum, mostly, again, like the other teams said, from the aviation industry. They are pretty good resistant to corrosion, which happens a lot in salty water. And we use lots of 3D printed parts as well, because they are easy to manufacture, and we can change them pretty quickly, and we get them pretty quickly as well, so they are cheap, quick, and we get a response for them. They are used mostly in our steering system and some parts in our propulsion system. During the building process, we have faced lots of issues and problems. For example, we had some delamination, like that's a typical fault of the composite structures. Then we had some not unprecise manufacturing. It happened a lot, especially with metal parts from when we got our CNC milled parts ready. And our biggest problem is the unreliability of some of our suppliers. I think for them, like they are not keeping the deadlines as they should or as they promise us, so they make some delays. But we always solve these problems. And we used to have some design flows as well, like everyone else, but that's how we learn, and we always check, then have a meeting about it, and we make lessons learned and a reminder, like, you shouldn't do this the next time you repeat this process. Yes. The biggest project for us was this year, our new rear hydrofoil design. It's composite and aluminum hydrofoil. The cause of this design is simple. In Hungary, we are limited with some of our suppliers to manufacture it. So to speed up the milling process itself, we wanted to have something smaller to mill out. So that's why it's split up into three main parts, like an upper section, which is connecting to the boat, and it's milled out from aluminum completely. We've got a middle airfoil section. It's carbon fiber composites. And the lower section, because of the bearings and their tolerances, again from aluminum as well. To get to this solution, we had made another iterative cycle. Like we made a preliminary design for the composite FEM simulation. Then we made a design for it again. Then we made another simulation in CFD. And then we evaluated the results. And again, we made a circle until we got the results we wanted. Thank you for your attention. And if you've got any questions, feel free to ask.
Thank you so much. Do we have some questions on the stage? Yes.
Well, I saw your iterative process with the propeller. I was just wondering, because the calculations of the simulations takes up a lot of time. So you know, is it not using a lot of time to do it in this way, and how are you dealing with it? Because it requires a lot of computing power and that sort of stuff.
Well, mostly I was not present in Hungary, and I had a workstation there, so I could use the CPU there all the time, so it could run. But yeah, it took a lot of time, and this year I meant from last July. No, not July. We started the project last March, so it was pretty long run project.
Okay, so it did run for a pretty long time then.
Yes, yes.
Okay, thank you.
Thank you.
Thank you. And I have the question because we do not see many Hungarian people, architects, and while some with the one we see doing some beautiful design. How was you inspired to go in such a competition? Basically, why you are here? Is it the inspiration was okay? I want to be a boat architect and I want to do this event. Or what are you here today? What's your aim?
So basically our aim is to work with something that relates to our studies and our main interest, but can lead to basically a more sustainable future, and to use and mostly develop our knowledge in a way that is interesting and also sustainable. And we wanted to do something different, and that's why we started building the boat, because we have a lot of Formula teams in Hungary, for example, a lot of car teams, but no other boat team yet, and we wanted to try something different that we couldn't find at home.
So, good job to be a pioneer. Thank you.
Thank you.
Excuse me. Okay. Thank you for the presentation. I'm just wondering about the reasoning behind the component selection of the microcontroller unit. Why instead of using Raspberry Pi that's based on the Cortex M0 Plus architecture, why you are not using x86 or the AICCP architecture, or even a better one like the Cortex A or the Cortex L series? Thank you.
The main reason we use this microcontroller is that we can easily source it, because we had a lot of difficulties with sourcing more common like STM32s and other microcontrollers, and we wanted to find a part that can be reliably sourced. And also I think it has a really interesting architecture with some more unique peripherals, and basically that's the main reason. And also the thing is that the dual core is also interesting, and as I mentioned earlier, one of the main goals of our project is to develop our knowledge in and to learn new stuff, and I think it provides a very unique opportunity for this.
Thank you. And sorry for the questions that I did not see in the front. So the next team that has to go from the next tech talks is on the energy class. Can we please have on stage Hydros team? I have to say that I like the name. Huh? So this is a remote. You have a screen here.
Oh,
you have 5 minutes. Do your best and good luck.
Hello guys,
It's okay.
Good afternoon. We are from Hydros team Universitas Indonesia, and I would like to start our presentation using Indonesian idioms that says tak kenal maka tak sayang, and it will be translated in English into if we don't know each other, we cannot care for one another. So first, let me introduce ourselves. My name is Emerald, this is Ganta, and this is Rifki. And yep, Indonesia is the largest archipelago country in the world. And if you're still not familiar with Indonesia, some of you guys have heard about Bali. and it's very famous for its natural beauty and its tourism. And yep. Anyways, as the largest archipelago country in the world, I don't see Indonesia being that advanced in yachting and or maritime technology development. So therefore, we are here not only for competing in on-race category, we also want to broaden our knowledge for our developing country. And this is our cockpit. We got the idea for our cockpit is from the F1 in around 1980s. And for me, it has aesthetic views, aesthetic looks, and at least it has aerodynamics shape. And it has cavity to lower its center of gravity, and it's only weighs around 35 kilos. And this is about our production. It only took us around 3 months, and the cost is around 3,000 euros.
Next is the conception and method for design the mechanical system. So our boat using the azimuth propulsion system with L-drive configuration and using the mechanical steering system because it's reliable and flexible. And we use a customized NACA 0015 rudder to achieve the lesser drag and better maneuverability at the high speed. We use the 10 kilowatt brushless direct current motor and 5 kilowatt hour capacity of lithium ion battery. So this is our production part of the mechanical. So we use the 3D printed ABS plastic, and then we cover it with composite, such as carbon fiber, epoxy resin, and aluminum for the outer to smoothen the surface. And then we use the aluminum material for the tubbing and the housing. For the moving part, like gearing and the shaft, we use the stainless steel. It took about 3 months to build this kind of thruster and budget around 550 euros. The problem we face is that the reliability of the material is not good enough to hold the vibration of the ship. So this is our testing and results. We did the results. We did the testing on Kenanga Lake, Universitas Indonesia, and our boat can achieve 26 kilometer per hour by only 65% of throttle. So, but it still rising up. So the top speed will be more than that. But due to our limited space in Kenanga Lake, the top speed cannot be achieved. The next. And this is the life cycle assessment. So we manufactured the cockpit back in 2019. It means the cockpit has bringing the 4th generation of Hydro Spirit. And then we use the reusable part of our cockpit is our boat is the battery, solar panel, and others material. So this is the waste management of our composite. We can use the pyrolysis method, or we can evaporate the epoxy resin to took the reinforcement and core material and use back in the next project. And this is the eco design. So our ship using the propulsion system, 100% electrical propulsion system that utilize sunlight. So the carbon footprint can be reduced to almost 0%. And then when we compare to internal combustion, the internal combustion can produce about 2.62 kilogram of carbon dioxide. And we we achieve the lower energy consumption by using a lightweight material in such a propulsion system and a steering system, and because of that, we can deliver the power to the propeller efficiently. Okay, the next. This is the main innovative feature of our boat. So we using the cavity. What is cavity actually? So we make the place of our beam. We cut the cockpit. For the same design of the cockpit, we can achieve 15 kilogram lighter than the same design. So and the next is by integrating telemetry system by using the LoRa technology. We can deliver the data from the boat, such as the ship velocity and then humidity and anything else to the computer. This is the industrialization of our project. So the propeller we made is from the material of composite, but with ABS, 3D printed ABS as the core material, and then we coated with carbon fiber. So we could manage the reduce the cost of the production. And this is the evaluation for our next our project. So the cockpit has no life cycle assessment, and the mechanical is unreliable material for the thruster. All right, this is the next project for Hydros 2023. We want to make a cockpit based on the latest generation Formula E car and using the biocomposite. This is our next project. We want to use the biocomposite such as flax fiber, but this is very challenging in Indonesia because in Indonesia there is no supplier for supply the biomaterial. For the mechanical itself, we would like to build our outboard system by itself using the more reliable materials such as steel and aluminum. Next, I want to share with Gavin.
Okay. Thank you for the handover, Rifki. Currently, the theoretical system of a boat consists of a couple of independent subsystems that requires quite a lot of space, involves very complex wirings, and needs relatively comprehensive core system. Furthermore, a large amount of time, energy, and budget is mandatory to maintain, service, and operate the system locally. All of this introduces sizable dilemmas such as inefficient use of the already limited available area for the theoretical system, complicated maintenance and operation of it, super capability between infrastructure, time-consuming revising of security, as well as ineffective usage of the finite resources. Henceforth, to solve them all at once, we will focus on 5 major factors in system design. That is modularity, repairability, upgradability, durability, and stability, with the first criterion as the fundamental of the concept for the future ethical project of ours. Okay. To simulate as well as demonstrate the concept of the next ethical project, a telemetry subsystem prototype that is based on Arduino and compatible peripheral alongside sensors are developed by using Arduino IDE, C language, Deep Trace-Ride, and Proteus X Professional. This sub enables us to monitor air quality index of the surrounding environment of the boat, measure temperature and humidity value of the system, and detect any kind of liquid if it leaks to the vulnerable electrical compartment. The material that are going to be used per se is frame retardant 4 as the base of the printed circuit board, as well as accurate as the enclosure of the subsystem. The potential problem that we may face itself is the quite high cost of development of the sub. Moreover, the complexity of the design, as well as rigorous simulation and evaluation, might potentially extend the development time. Therefore, further optimization, while of design, component selection, or budget management, alongside top-down efficient approach toward the build of the sub must be done extensively and wisely, and are vital parameters in the fabrication. Now that we come to an end, we all have to say a few words. We believe the development, the progress of improving ship technology, both major and minor, that happens well in the past, in the current, in the present or the future, in this very own place, mean the betterment of the living of standard in a lot of developing countries, let alone in archipelago ones like ours. Thus, we would like to humbly thank you, everyone in here, for your passion and dedication towards the investment of this section of technology. For all those hard works of us mean we could help so many people in the long run, for we leave a tremendous amount of significant, crucial legacies for our descendants, the next generations. Thank you.
Congratulations. I know that we put you the rush on the 5 minutes, but you can speak sometime a bit slower. Is someone have some question? Yes.
You said that you couldn't get your maximum speed due to the size of the lake. Have you tried getting to your maximum speed on the sea or not?
Unfortunately, we cannot make it. Our boat cannot make it here because due to our logistic problems, and yeah, it was delayed. Sorry.
Oh, that's sad. Hopefully next time.
Thank you. Do we have another question? Okay. Jury?
No, very quick comment, not a question, but a comment. I think if you going into biocomposite, it obviously is because you're looking at more, eco-friendly solutions, possibly more recyclable, possibly more, in the usage. And so obviously, if you cannot get that in 2023 in Indonesia, try to, get some other partners, local partners in Indonesia on raw material, whether it's wood product, whether it's that would be really interesting to see something that comes from local supply, local procured. So I think it's very nice that you're already looking forward to the next project, and it'll be easier for you to link it with your current boat. And I think that's inspiring for many teams, that point. But yeah, if you can try to supply it in Indonesia, we would love that. Yeah, for sure.
Thank you. I have a little question because the speed that you test is quite amazing due to the amount of energy you have on your engine. Have you made some calculation about CFD analyze about the drag of your boat and what will be the best pitch of the boat in order to reduce the drag?
For the optimum pitch on the propeller, the optimum pitch of the propeller
Of the boat.
Pitch. Maybe about 3 degrees or. Yes, but actually it's not being tested because our the CFD is not compatible with our study in University of Indonesia. So we need to do the research more with other partners like maybe Chroma in our country.
Okay, Hello, merci. We will have to support you with the CFD software, and if you can go back on the slide of the previous boat, I am asking you this question because it looked like that the seat of the pilot will be, in my opinion, a bit too on the back, so you should have the CG2 on the back. That's why I just highlight you that. So if you go on this after, you see the new design for the next year. It looked like that you just take the picture about the new Formula E, but the weight will be too on the back. So just watch out about it.
Yes, actually.
Thank you.
Thank you very much.
Okay, so now can we please have on stage the team number 8 of today. It's still an energy class. I really like them. They come from Portugal. Técnico Solar Boat. Could you please come on stage? And we are used to have beautiful tech talks from you. This is a remote. You have the screen here, and you have 5 minutes.
I think mine is not working. It's working.
Take this one.
Thank you.
Well, good evening, everyone. My name is Mafalda Abreu, and I'm the team leader for Technic Solar Boat. And I'll be presenting our hydrogen-powered boat, which is the boat on the left, with Luís Azevedo, who is from the Hydrogen and Fuel Cell Department. We're a Portuguese team from Instituto Superior Técnico, which is a university that it is mainly known in the country as one of the best. We were founded in 2015, and right now we are a team of 76 students. We're all studying while we are in the project. We all work in both boats, so in the solar and in the hydrogen one. And besides that, we are also developing our first autonomous solar-powered boat. So our design to this boat was in order to achieve the greenest prototype that we have ever built. Besides accepting the challenge of going into the hydrogen world, we would also have a hull that it is as sustainable as possible. And for this, we reused a former student mold from a team from our university. We used flax fiber instead of carbon fiber. We used recycled PET core instead of PVC core. And we also used a bio-based resin from Sycoma.
So, what do fuel cells need? They need air and hydrogen. Besides that, they need control, and a very precise control. Of what? Temperature and humidity. And that was the main problem that we faced last year with this exact model. We didn't have a proper control of humidity, a proper control of temperature, and our controls for example, for the radiator were also not very good. So what we did for this year, we had a humidifier, a new radiator design, more sensors to know what is happening in the whole system, and we can do a better control of the whole system. And next slide. And this is our new Belasov plan schematic. As you can see, there are new components, like there is a water trap, the humidifier. I will explain that later, but we have better results already with this new system. So this is our CAD design. There is an air blower, already the humidifier that I talked before, relief valves, the solenoid, and other components. So what is the purpose of the humidifier? As you know, a fuel cell, the hydrogen admission has to have a humidity between 80 and 90%. So what we are using this humidifier is we are using the exhaust of the air to humidify the inlet of the air. And why do we need to have humidity in the air inlet? Because we don't want the fuel cell to get dried inside of it. Because if the membrane is dried out, then the efficiency decreases, and then the fuel cell overheats. Then, of course, we have to do a lot of testing. As you can see, we tested the new sensors, we tested the new radiator. We have some graphics. Next. We have some graphs. This was before we implemented the humidifier and the radiator, and you can see in the anode tempered exhaust, we pulled like 2 kilowatts of our 5 kilowatt fuel cell, and it was already overheating at 70 degrees. So now we expect to have better results. So this is our new radiator. Besides the radiator as a new design, we also add fans to have an induced air through the fins to have the water that is cooling down the fuel cell a better gap in the temperature. So this is my favorite component, and why? Because this was all developed in-house. So I will tell you a story. As you know, most fuel cells need some kind of water trap solution because water condensates inside of the tubing. But there are not many solutions for this. For example, we talked with a company which is OMB Saleri. It's an Italian company. But they couldn't sponsor us because the manufacturing of the component for our system was very expensive. Then we have, for example, like those available commercial water traps, but they are efficient, they do the job, but it's not an elegant solution. So what we did, we designed our own system. So in the vertical section, the structure, we have tubing passing, and what is the objective of that tubing? We are forcing the hydrogen to go a longer way to have the condensation being done in that tubing, then the water condensates, and because of the degree of the tubing, the water flows and goes to a reservoir. And why this solution is so good, in my opinion, is a passive solution. There are no sensors. It's all based on. Can you do the next slide, please? Yeah, it's all done based on our finite element studies, and if you think it's a more efficient solution because there are no electronics, there are no power being used here. So it's a more efficient way of doing this type of control. So one of the things that I talked is the problem of the water trap. In the industry, there are not a lot of. We talk a lot about the hydrogen economy, and there are a lot of funding for green hydrogen and for funding, but there isn't a lot of funding for the equipment that is needed for the applications. And that's what we are doing here. Not only for the water trap, but for example, the humidifier. A humidifier costs around 1,300 euros. It's a lot of money for a single component. And this one was one of the difficulties of our team.
Now, regarding the life cycle assessment that we have always wanted to do to prove that our monocoque is really sustainable, we must see that we will do a comparison of what we have and what it would look like if it was made with carbon fiber and PVC core. We must take into account that the end of life of the materials lies outside the scope. So inside the scope, we have the transformed materials and the production that we did. While we were constructing the boats, we realized that flex fiber required twice the resin and twice the layers of fiber when compared to carbon fiber. In this analysis, it was not taken into consideration that we used the bio-based resin from Sycomen because in the database we couldn't find anything similar. And also the reused mold from the Formula Student team was not taken into account here. We divided this into 3 parts, so we have the system box, the cockpit, and the other components as the seats and the headrest, for example. What we can see is that when we analyze, because this measures the impact and the damage of each category, and we can see that mainly the solution with the flax fiber is always has a lower impact or damage. for example, in the cockpit, we can see that in the global warming and in the ozone formation, we have half of the impact that we would have if it would have been made with carbon fiber. And in the cockpit, in the damage categories, we see that all of them are better with our option. So, are flax fiber and PET core sustainably better than carbon fiber and PVC core? Mostly, yes. Our biggest difficulty while doing this analysis was to find the database that had our specific materials. We considered doing our own, but it had a lot of complexity and data that we didn't have. So we tried to find one and try to do approximations to have the better analysis we could. But we concluded that, yes, we did it. We achieved our goal to have a completely eco-friendly boat. Thank you so much for your attention. We are now open to answer your questions.
Well, thank you very much for the talk. I've got more of an organizational question. I saw that you have a team of 76 people, mainly part-time and working on both the hydrogen and solar boat. How do you...
And the autonomous.
Okay, so how do you make sure such a large group of people stays focused on their own tasks and keeps working towards the same objective?
What I feel personally is that I have an amazing team of leaders of each area. And when I feel that I can trust them, I know that they will just organize the rest of the team. Of course, that when we are recruiting, we try to find people not that have the most knowledge on the situation, but yes, that are willing to give time to the project, learn, and love to be here. Yes, it is hard. Sometimes there are some people that start to struggle, but I think we always try to act as a team, try to help each other, and not transform this into something that it is hard, because university is enough, I think.
Do we have another question? In fact, I do. I am quite impressed by what you try to develop by yourself on the fuel cell. But could you please explain a bit more in details about what kind of fuel cell are you using and why that was very an issue, this humidification? We understood because due to the efficiency, you try to increase the humidification. Unfortunately, you did not test. Do you have some result about this new product? Because I guess that might be a good thing for some of the friends which are in the room. But do you have the result about this idea that you involved in your boat?
So our fuel cell is a 5 kilowatt PEM fuel cell provided by Netstack. So the question about humidifying. So last year, in fact, in the manual of Netstack says that we have to have some kind of mechanism to humidify the air inlet. But last year we ignored that, and we expected that the humidity in the air that is going to be sucked by the blower would be enough. It wasn't, because already with the test that we have done, we have a better temperature control only with the air inlet. And one of the things that was happening without the humidifier is that the fuel cell would increase the temperature very, very rapidly. And why was that? Was the efficiency. The efficiency was going down with the drying of the fuel cell, and that was one of the things that we concluded. Also, we researched some academic papers, and most of them said that the air needs to be humidified between a range of 80 and 90%.
Just to continue, can you explain how the humidifier works?
How do you? Okay. So we have two inlets and two outlets. So there is an inlet that is for the air exhaust, and the air goes from there to another outlet. Then there is an inlet for the newly refreshed air there that is being sucked for the blower, and it goes from the fuel cell and it passes from there to the fuel cell intake. But how does it work? So our company that gives us the humidifier has something that are Nafion tubing. And Nafion tubing is like a membrane that allows the humidity passing from one tube to another. So yeah, it's a proprietary technology. For example, Permapure uses the same technology. Nafion tubing is very expensive, and because it was a proprietary technology, and that's one of the reasons why humidifiers are so expensive. For example, Toyota fuel cell stack, they don't need humidifier. The fuel stack is self-humidifying, which is very difficult to do because they have to design the inside channels from the stack to humidify the air. But most available commercial fuel cells need humidifier.
Thank you, great answer.
Yeah, hey, I have one more question about your water trap. I'm always really excited about people being excited about products that they create. I just want to know what the efficiency is of the removal of the condensed water of your solution, and if it creates any problems, because there's always a trade-off with these solutions.
Okay. The efficiency, we didn't at the time to do the calculations and to have proper testing. Why? Because the inside of the bottom part is very difficult to 3D printing, and we had some problems with that. But comparing some tests that we did with this water trap and a commercial available solution that we also have, because we have to have redundancy in our system. If that didn't work, we have to add something for Monaco. And until now, we know that at least that works. I don't know if the efficiency of this is better than that, but at least I like more the design of ours than the other. And I think that counts for something.
That counts. Congratulations.
Thank you.
And I am sure that plenty of people working from InnoCell and Symbio will come to your team to hire some engineers. Well, now time is going. Can we please have on stage the OpenSea class, the very good team, the winner of last year, TUDELF Hydromotion team. Could you please come on stage?
Bonjour, hello everyone. I hope you have a fantastic day fantastic first day of the competition. We enjoyed it a lot. I hope you guys did as well. I noticed that the attention in the room, the concentration in the room is slowly slipping away. So I'll try to keep it a bit short. Yes, next slide. Yeah, we are the TU Delft Hydromotion team. My name is Mannes, and besides me I have Olaf van Voorst, our chief. Yes, exactly. All right. Yeah, we are the TU Delft Hydromotion team, and in just 1 year we go through the process of designing, building, testing, and racing a hydrogen-powered boat. This is quite a challenge, and for this we need quite a lot of man hours. So that's why we have a team of 25 driven students from the TU Delft, who for a full year set their studies aside to work on this amazing project. We are from the Netherlands, and the Netherlands has quite a rich history, rich maritime history, and is home to various yacht builders, among which are quite some yacht builders in the harbor today. such as Vetship and Royal Huisman, which are also partners from us. So that was quite funny to see when we arrived in the harbor a few days ago. We are from the TU Delft, and the TU Delft is a university which is ranked among the top 20 best universities in the engineering field. And yeah, we of course are a team from the TU Delft, but we are not owned by the TU Delft. So we are a foundation, and that results in the fact that we can make our own decisions. We are not bound to that many rules of the TU Delft, so that's quite convenient for us. Yeah, and this year we are the only student team in the Open Sea class, which is also quite challenging. We are up against quite a lot of commercial parties here today, such as Vita Yachts and Ixshore. And we also have quite some experience, but that's mainly in the solar class. So for like 15 years, we've been designing solar boats, with which we also raced here in Monaco in the solar class. But last year's team, they decided that it was time for a new challenge. After doing 15 years of engineering solar boats, yeah, we were looking for something new, a new challenge. That was hydrogen. So in just 1 year, we made the switch to hydrogen. From solar energy, we switched to hydrogen. And we took the hull of 2019. We was the winning hull in the Open Sea class at that time. And we completely refitted it to a hydrogen boat. This inspired us, of course, to do something great again this year, which is to build a hydrogen boat that's fully optimized for hydrogen instead of just a refit. Yeah, this team is structured in different departments. So we of course have a full-time management. We have powertrain, which is responsible mainly for the hydrogen system. We have vehicle dynamics, which are responsible for the mechanical parts of the boat. We also have electronics. Yeah, that one goes for itself. Then we have hull and body, which designed a very special hull, because this is the first year that we have designed a mono hull that is seaworthy. And Olaf is going to tell you more about that in a second, but that's a quite special thing that we did this year. Of course, we also have operations, who is responsible for the non-technical side of the project. Yeah, there you see the inspiration that I just talked about, the hydrogen boat that we built last year. This year we have built a completely new hull, and part of the inspiration that came from that is the Luna Rossa team, because they also have a foiling mono hull that's seaworthy. So yeah, that gave us some inspiration to build on this boat this year. Now Olaf will tell you something about the more technical side of the project.
There you go. Thank you. Well, thank you, Manas, for the quick opening. Yes, as you can see on the picture, we took an inspiration of last year, and I can't stress enough that last year they made the switch to hydrogen, which was a very big change, but they were not able to make a complete new hull because they had lack of time, COVID and whatnot, and that's the first time that this year we can fully make a hull used for hydrogen, and that's what we did. So, quick specs about the boat on the right. That's the hull of this year. It's a hull of 7 meters long, made out of carbon fiber. It's 2.4 meters wide and it can carry 3 persons to participate in the Open Sea class. We use a 40 kilowatt proton exchange membrane fuel cell, which powers the motor as well as the buffer to keep the dynamic response of the fuel cell in line. We carry 2 tanks on board, 2 tanks of both 8.4 kilograms of hydrogen at a pressure of 350 bars. So we have plenty to go complete the endurance race at our max speed. And so that's what we aim to show this week. Yeah, so more about the concept, how we came up with the design. So, as I already said, it's now the first time that we could make a hull designed for hydrogen, and that's what we did. We made a seaworthy mono hull, which was the first time in the foundation. This hull was made semi-planing, so it can cross the regime between water displacement as well as foiling as smoothly as possible without as much as resistance. So yeah, the 3 foils below, make sure we get out of the water and have less resistance, as you all know, of the solar classes. Some optimized programs we used finite element analysis. This we use to completely make the structure of the boat as light as possible, but as well as can carry all the loads to make sure it functions properly. We use 2 propellers. Propellers are designed with one of our partners called Marin. And these 2 propellers we have made to make sure we have the best performance under different conditions. So, from concept to production, here comes a funny thing. So, we made a boat out of carbon fiber, so it's a composite structure. And this year we decided to use a different technique. As you might all know, pre-preg is much often used as well as the solar classes, but as well last year. But this year we decided to use a different technique called vacuum infusion, a technique where you put the layers in the mold and you suck the resin through it. And we chose to do this because it saves a lot of time. And this is quite an ambitious project to finish in 1 year. And that's why we decided to use this technique. It's also for the company where we did it, Contest Yachts, is a yacht builder in the Netherlands. It was for them also the first time that they made a complete hull out of carbon fiber with this technique, vacuum infusion. Let's go back one slide, yeah. And we succeeded. We shaved a couple of weeks off our production time of the hull. And I'm sure that if next year uses this technique again, if they're gonna make a new hull, they can shave a lot more weeks of the production. Our total production time was over 5 months. We started in December and we only finished around halfway through May. And that's mainly due to the problems we faced, lead times due to the pandemic. Our fuels arrived very late. That cost also not as much testing time as we wanted in the first place. As well as hydrogen is still a very new sector. It's hard to find professionals that can help you with that. But that's what we aim to develop over the years in our foundation, to get more experience in the hydrogen sector and to show what's possible. But then to the testing, as you might see on the picture as well as on the graph, we have not been able to go fully foiling stable yet. We're sure the boat is capable of foiling stable, but we had not as much testing time as we wanted. And as you might realize, a boat of this size and weight, it's quite hard to stabilize on 3 sticks. So we're sure it's capable of doing it, but during testing we managed to also look at the effect of this foil-assisted planing, and we could really see a decrease in resistance of 20 to 30%, and that's why we can achieve a top speed of over 20 knots. But we're sure, as the graph shows, we can achieve higher speeds with the same resistance. As well as the boat weighed only 200 kilograms after the production with vacuum infusion, and the total weight sums up to about 1,400 kilograms. That's including the crew members as well as the pilot, all the components inside. So yeah, as well as the fuel cell that arrived quite late. We did have a fluent integration with that, so we're really happy with that. It was nice to see that it was it was quite good to cooperate, and we managed to achieve a lot of testing time, but just not enough to get the stable foiling. Well, yeah.
Yes, perfect. Yes, after because of the way that our team is structured, we always build forward on the knowledge that the previous years gained. This also counts for the mechanical part of the project. So also, for example, this year we reused one of the tanks from last year to number 1 thing. And coming year we'll probably recycle a lot of diggings in this boat. They probably will recycle the complete hull. With that, they could recycle the rear strut, Maxons, a lot of things. So, and also when we made the change from solar energy to hydrogen, the solar boats were put to demonstrative purposes. For example, to show that it's possible to sail on solar in museums, for schools and other things. Yes. Our eco design, we use green energy. We use green hydrogen. But we all know that green hydrogen is pretty limitedly available. So we try to use this as efficiently as possible, and this we do with our foils, of course. Also with foil-assisted planing, we already can use can sail quite efficiently. Let's go to the most innovative part of our project is the whole thing. So we made a complete, it's the whole boat. So we made one seaworthy monohull that's sailing on hydrogen, and all these things coming together in just 1 year. It requires a lot of time, effort, and that's the most innovative thing about the project. Yeah. Yeah, the industrialization of the project. About 8 years ago, there was a spin-off from our project, which is called Flying Fish. It's a startup that is run by a few alumni of the team, and they're already making these things on the market. So they're already making ferries, high-speed ferries that already sail in Rotterdam, and they also plan on making these foiling. And throughout the year, together with our partners, we try to make this world a more sustainable place. And so let's sail together towards a more sustainable future.
Congratulations. Do you have some question?
Hi. I have a question about the energy management. How is your setup? It's a series or a parallel configuration? Is the battery always connected to the motor, or the fuel cell is sometimes only connected to the motor, or is it has the two configurations?
Well, thanks for your question. Maybe you can go back to the slide where you can see the inside of the hull, the internal architecture. Yeah, so the three things, we have the buffer in the front, that are batteries. We have the fuel cell, the red thing in the middle between the tanks, as well as the motor in the back. They're all connected with one bus. So if the motor requests more power, then the buffer will probably give the power, as well as the fuel cell slowly peaking up as a dynamic response. The other way around, if the motor requests less power, then more energy will go into the buffer. So it's always connected, and we don't disconnect these two. So yeah, that is a fluent integration, yeah.
I've got a question. Sorry. I have a question about the explosion safety of using hydrogen.
Yeah.
How did you guys handle the risk analysis, or maybe the flow calculations inside of the hull?
So last year I already made the step to hydrogen, and so there's a lot of experience with finding out the dangers with hydrogen. Of course, it comes as a risk. It's an explosive gas, if not treated correctly. And so we made the calculations, like if a power rupture occurs of 1 millimeter, for example, what would happen? And for that, we decided to make the tanks in a separate compartment, and this compartment is passively ventilated as well as actively ventilated. So if a rupture would occur in the tanks, then the gas will probably fly off, but there are some openings in there for passive ventilation. We also have, like in the middle, there's a possibility of a hydrogen leak. And there we use only active ventilation that's constantly flowing, even when all the other systems are turned down, to release the hydrogen into the open air. And that's how we make it safe for us. Yeah.
Just continuing in this question, I know that your idea by designing this boat was maybe to industrialize this boat. So have you already considered not only the life cycle analysis, the risk analysis, but just the certification? Had you follow some hydrogen certification while you design the boat?
You mean about hydrogen certification, how it can be implemented in the larger scale, you mean? Or yeah, so with contact with a lot of partners, we looked at these certifications, looked at how it can be implemented. And so the regulations we have to oblige is all the same for the open world, the same for all the companies. So yes, it's the same. It's easily can be translated to the maritime sector or to other sectors, and so it's not a separate rulebook for us in that case. Yeah.
So I want to ask, first of all, greetings for the amazing job. I want to ask about the way in which fuel cell and battery pack are integrated. It's like a passive integration, so they just connect by their different voltage and current characteristic, or is something that can be directly controlled? So, I mean, I can decide how much power I can take from fuel cell and battery, or it's just passive integration?
Very good question. Again, yeah, so as I said, they are connected with the same bus. And just after the fuel cell, we have a DC-DC converter, which can scale down or scale up its voltage. So it can make sure that the batteries are charged, or the buffer of the motor gets its correct output voltage to operate as its peak performance. And so yeah, it's quite a fluent transition, and we can just ask the fuel cell to generate more power. It will speed up, or just lower its power, speed down, depending on the state of charge of the buffer, for example, or the request of the motor. Yeah.
Thank you.
We have plenty of other questions, but we are out of time. Thank you and congratulations.
Well, thank you, guys. Thank you for listening.
Thank you and congratulations. Now, can we now please have on stage team from Energy Class, Naila Puni. Can you please come on stage? And that is supposed to be the last one, but after I have an important question to ask to all of you, so if you can stay till the end, because we have all together to decide about the future, about Wish Power Solar team, because I had some information why they were not here. So I need your decision and maybe your help to take the decision. Thank you. You know the rule, you have 5 minutes, you have the screen. And good luck. Ah, yes. No, 5 minutes. Yeah.
Okay, thank you very much. Good evening, everybody. My name is Diego Arroyo. This is my friend Victor Celada. We are from Peru. And well, it's a beautiful country. Actually, I think it's very known by Cusco, where is Machu Picchu, one of the 7 maravillas of the world. And a little about our country or university, I mean. Well, we are from National University of Engineering. It's one of the most important universities in this field. I mean, engineering, in my case, mechatronics, and in this case, mechanical electrical engineering. Well, about our team, we are a multi-general careers team because we are we have a lot of careers. From engineering, economics, marketing, etc., because we need financials to solve our problems about principles. And well, what more? A little about our mission. Maybe we are making some projects in the direction of marine sector to compete and represent our country and our university. The next, please. Like I said, we are a lot of people. Well, the next please. Okay, now you.
Okay, thank you. About our inspiration, we take the chassis of a race car. Because of its structure, its chassis, it would be very optimal for the requirements that this challenge is has asked for. A structure very kind of aerodynamic with facility of being moldable. The boat and propulsion characteristic we had is our structure is mainly composed of aluminum and stainless steel structure. It is an descendable structure, and we have an outboard motor of 48 volts. We've used lithium batteries, but we have an issue with that. We could talk about that later. We've used an electric propulsion, and we've planned to use solar panels.
Okay, about the concept, methods, design, and optimization. We use some softwares, especially software like Inventor, Maxsurf, Rhino, etc., etc. In this case, we can see our structure, which is of stainless steel, and aluminum. We use, in this case, just SolidWorks and Inventor. Well, also we have a rendering of our design, and we can see the construction, which takes place in the marine of our country, because, well, our university doesn't have a special place to make these kind of things. And the next, please. Well, I mean, we have some laboratories, but when I say we don't have this place, I mean some place with a lot of water, like a lake or maybe a beach or the sea. Well, but we have some laboratories when we used to do something like this, soldering, welding, some kinds of manufacturing like this. Well, we find some problems with the structure, the transporting planning, obviously the COVID-19. And well, about the budget, we are near for 15,000 euros, and the time of production actually was a little more than 8 months. I mean, it's just near to 1 year. The next, please.
Okay, as I mentioned, the problems we faced, apart from those, when we arrived, we have the bad news that our batteries weren't able to come with us. So the moment we were in Nice, the place where we arrived when we came from Peru, we started to look everywhere the way that we could get another battery with the same or near characteristic that we had. Unfortunately, we didn't find the same one. We planned to use two of them, but we just had one. It had the half amount of capacity of that the challenge is restricting. So we tried to adapt that to our circuits, and we had some issues that since the day one we've been trying to repair and connect, and we are still doing that. Apart from that, we would say that because of that, our solar panels wouldn't be able to connect to. So the majority of our efforts we won't be able to present here. I would say was the main problem that we faced once we arrived here in Europe. About the testing results, because the budget in research competition is always present, the condition of testing and measurement that we had were the strength of each materials of the boat, which we've constructed our structure, our directional system, the load that we were capable of our capacity of load was 245 kilograms, and the hulls that we used to test them were of a lower capacity. As you can see in the picture, if you look closely, you can see that they are submerged because they are of a smaller size than the Monaco would give us. Also, the separation of the hulls between was shorter, so that would limit our maneuverability, our velocity. But in the end, the results were that our cockpit is solid enough, our manual directional system works as well, and we managed to determine the maximum speed under these limitations, which was, I would say, 11 knots, kind of around 20 kilometers per hour.
Okay, previously a little more about the velocity that my friend said. We just near to 11 knots because we don't have the suitable holes. But well, about the eco design, we used a recycle or reused seat we were actually used for a helicopter. It was a donation. And obviously, maybe the semi-rigid solar panels that includes the clean energy and, well, the power outboard electric motor. Maybe you can say this is very obvious to use this kind of energy, but in our country it's a little strange to use this kind of energies. If you look around our country, you used to see engines, outboards. So that's it. The next, please. And well, about the innovation, it has a relationship with that idea. Because if I said use electric motor in Europe or maybe in United States, it's so natural. But in our country, it's very strange. Also, the design of a photovoltaic system with the implementation of flexible solar panels, because at the beginning we try to use or try to design something very complicated, but in the middle of the project we noticed that this require more budget, and we decided just change that idea, and in that moment we hacked the flexible solar panels, and that is some months ago we said we had to buy the solid solar panels. The next, please. Okay.
Okay, finally, for the industrialization of this project, as we've mentioned, we don't have too many innovation if we compare it to what other teams have presented, but in our country, this is very rare, and because of that, we've managed to catch the attention of some interesting organization who has lent us a hand. For example, let me see. For example, the National School of American Navy, the Peruvian Canoeing Federation, and the Marine Industrial Service called CIMA in Peru. Those three gave us a place to make our trials for our engines, structure, panels, and batteries, all of them assembled, even though we had some limitations. And the last one, Cochacashu, is a very interesting one because it is a biological station. I wasn't able to go there, but my friend here, yes, and so he's gonna give us some details.
Yes, it was a very exciting experience because it was our first experience in this kind of, I don't know how to say, I mean, we usually live in a city with a lot of buildings and everything, but when we went to that place, it was very strange because there was nothing, just some natural animals, some communities very far away, and well, also people don't know about the current technologies. And our goal in this project was to study the current state about the solar energy in those places, also the technology used in their boats, which were made by people who doesn't have studies about this. And also about the electric motors, because they don't know about this kind of technology. And also, this is, well, I would like to thank this company, which was San Diego Global Zoo, because they invited us for help us and work together. And in conclusion, it was a really good experience. I think that's all. Thank you very much.
Thank you. Do you have some question? Sorry, I just need, if there is, to take the first one. No, it was crystal clear. I guess you are also pioneers for your country, so congratulations for that. And I hope that many other teams can support you and help you if you need. So thank you so much. I'm sorry for La Régie, but I made a mistake. Before, we were supposed to receive a solar team named Clean Mobility Team Solar. Could you please come on stage? Sorry for that.
No problem.
So you have the remote, the micro, you have the screen here, so you're not obliged to turn on the back. You have 5 minutes. Good luck.
Thank you.
And you need a second one?
Yeah.
Will be nice.
Yeah, we're from the Netherlands. Where we do our work is in Amsterdam, and we're from the University of Applied Science of Amsterdam. The project itself is named Clean Mobility, and here do we build our boat.
Yes, so we're from Amsterdam. Amsterdam is like the most populous city of the Netherlands and the nominal capital. Like Sunflare mentioned before, the Netherlands is the lowest country in Europe, with 26% of Netherlands below sea level. Due that there's like a lot of water in Holland, so it's really a really good place to have a boat. and test the boat. So that's why we're here with a lot of Dutch teams. Something about our university. The first time our school opened their doors was in 1995. Clean-Mobility, the group we're working for, started in 2008. Something about our team. We have a team of relatively small, 15 people. Our project is a second year project for mechanical and electrical engineering students. And this is a list of all the team members and what kind of roles they have.
Yes, we're now going to talk about the propulsion. We have a different propulsion from the rest of the teams. Our propulsion is the motor is underwater and the gearbox is attached to it. With the cables in the propulsion itself, does the screws go round, so that's how it works. And the motor is just downstairs and not up in the boat. Yes, next one.
Well, for in general, engineers work with like a very typical 7-step plan. As is mentioned in our presentations, firstly, define the problem. Secondly, gather information. Thirdly, identify possible solutions. First phase, prototype. Testing phase, refine and find a product. In our case, it was like testing our old boat. Our boat is built in 2 years. So the first year they completely built the boat. And yeah, there were like just a lot of things that could be just a bit more better. So we just tested the boat, analyzed the data and made some conclusions and integrate all the new informations into our new boat or the improvements for our boat.
Yes, and we made the boat in 2 years, what he said before, and we made it out of carbon fiber. It's the best material you can make a boat out, and a lot of other different materials, what other teams said. So it's like the same as every team. Our budget is 15,000 euros, and we do it. So every year there's coming a new team, and we're the team this year.
Yeah, because our main goal for the project is to have a boat that is mainly for like long distance stuff. We use a lot of plastic materials because it's just like it's really lightweight. So like PLE, ABS, PAG stuff for your 3D printer. So that. Testing. The location where we always test is the Amstel in Amsterdam, like the most common and main river in Amsterdam. Mainly we tested our propulsion and mainly our new propulsion from this year and our hydrofoils. And a lot of different setups with our screws for like different kind of speeds and stuff.
We began our product in 2008, and now since 2012 we made 3 different boats. So now it's the 3rd boat, and it's the best boat because it's lightweight.
Yeah, we reduced the weight with this boat with 50%. So the last boat was really big and really like a strong horse, you know. So we just wanted to improve with using different kinds of materials. We also had like intern switches with teachers. So a lot of new eyes with new ideas. So yeah, we just invented our boat completely. Also, one of the big changes this year was a new deck. On the deck, we installed new solar panels. So this is the photo of our new solar panels.
At least we invented a lot of things. So it's a hydrofoils, a boat propulsion, a bin for the electronic parts, a boat propellers, a cockpit, a new boat driver who's not in the boat yet but is coming, and a data logger.
Yeah, things like our hydrofoils. We have hydrofoils. About the boat propulsion, like other teams, a lot of other teams use like metal materials for their propulsions. We use composites for it, just because we just wanted to look all the way around. Yeah, and just
be creative.
Yeah. Search for new possibilities in that case.
Are there any questions? And thanks for listening.
Yeah.
Régie, j'ai allumé un nouveau micro, désolé. Can you hear me? Okay, merci. Thank you very much. Congratulations. Do we have a question? No, I guess it's time for. So now I suppose, could you please explain us a bit why? Because that's the innovation which I like the most. You just said that you have put the engine directly inside the water, basically, in the shaft. Could you please just explain why you did that, and maybe compare the difference of drag and efficiency between having the engine out and having it directly inside the shaft, and what's the difference of power?
Yeah, just like we mentioned, we said something about our propulsions, and because we were really experimental with our propulsions, we wanted to have
the making of this propulsion is very simple. So the propulsion of other teams is like gearboxes with rotating materials, and that's very different for us. If we just make aluminium things, we put it together and we make it our own. So we can make it with our own hands and make it as simple as possible, so we can.
This is clearly understood, but I guess you should have less power, or maybe increase the drag. I am more interested in that. Did you make the comparison between the power and the drag that you lose or not?
Yeah, we tested in the beginning of the year if it was very effective or not, and it's the. Where's the?
Yeah, like we just reduced the resistance of our. Propulsion, but mainly the reason we swapped from an engine inside the boat to the engine in the propulsion was because you can easily swap a propeller, because we just can put out our propulsion to swap a propeller. So it was more efficient for us to experiment with things we didn't know yet. So
understood. Thank you.
Yes.
So now I need your upload or not, depending, but I guess I know the spirit of Monaco. You know the rules is quite strict. If a team which is called and supposed to come at the tech talks is not here, he's banned for the competition, so they are disqualified and they cannot come. Unfortunately, that was the case of Whisperer Solar Team, let's say half an hour or 1 hour ago. Some of the team came to me and they apologized, and they give me in my opinion, a good reason because their boat was burning. So that's why they were trying to be a sort of fire hunter, and avoid, that's why they were not here. So if you agree, I give them another chance to join the challenge. Are you agree with that? So please, you have just 4 minutes to explain your project and maybe your what's happening today, because that might be interesting to some of us in order to avoid that.
So guys, thank you all for staying. Thank you all for this opportunity also. And yeah, I'm extremely sorry for being late, so thank you for this opportunity. Okay. Oh, we don't... That's not right, I guess. Okay. So, my name is Sander. I'm from the Whisper Power Solar team. We are a Dutch team. We are based in the northern part of Holland. So, I would like to try one more time. I don't know if it's working. No. Okay. So we actually are a team based from Drachten, which is a part of in the northern of Holland. We are a team of 5 people here in Monaco. So there it actually is. So the team is a private foundation which is called Whisper Power Solar Team, and Whisper Power is our main title sponsor. So Whisper Power is a company that makes silent diesel generators, battery power systems, and monitoring and control systems. So basically complete energy systems. So Whisper Power basically fits really well into our profile. So about the team, as I said, we're from Holland, so country is Netherlands. We're based in Drachten in Friesland, which is a northern part of Holland. Okay, I will rush. About the team, we are competing since 2014. We have a new boat since 2018, which is the boat you can see in the paddock right here. You can also see the team members of our team, which are actually competing here in Monaco. So quickly about our boat. Our boat uses a custom electric propulsion system, which is custom designed just for our solar boat. We also use a custom laminate solar deck, which we made ourselves in our headquarters at Whisper Power. We sold all the solar cells together, we put it in a laminator ourselves, and then pasted it on the boat. We also use carbon fiber propellers, which I will go in depth just later in the presentation. And we also use our own data collection system, which we can analyze just after the race. We can analyze all our data and see where we can improve. And we also, since this year, have our custom design hydrofoil system, which you can actually see on the picture in the left corner. So, just about our propellers. Just I said, we use carbon propellers. Yeah, how do we design our propellers? We use a program which is called OpenProp, which runs on MATLAB. With OpenProp, we can easily put in different parameters and see how this results in different outcomes. We can quickly iterate on the propeller design with OpenProp. And it's easy to produce in-house because we can very fast make different designs. From these designs, we can go really fast from OpenProp into SolidWorks 3D, which we have the propeller right here in the top corner, which is in 3D. And with SolidWorks, we can easily make a negative mold out of this propeller, which we can use in a 3D printer to quickly print a 3D mold. Well, you can see the production process right here. Yeah, as you can see, we have the 3D mold here, and we use carbon fiber and 3D printed PLA for the mold, and we use carbon fiber to make the propeller. And after that, we infuse it with epoxy and let it rest for a moment, and then eventually it becomes a propeller. So a few problems we faced here was getting the center cone, which is the piece right in the middle of the prop with the 3 holes in there, to get it fully saturated with carbon fiber and also with epoxy. So that was a very big problem we had in the beginning. Also the problem was epoxy saturation throughout the whole propeller, so throughout the blades, in the center cone, everywhere. And releasing it from the mold was also a problem. Right now we still have to sacrifice the mold to get the propeller, but we plan on designing a mold which can be reused time to time to create the same propeller again. So now comes the good part. Time of production for this propeller is around 1 hour to cut the carbon fabric and to laminate it. And after it's hardened, we need around 2 hours to release it from the mold and to post-process. So if we have to do this with an aluminum propeller in a milling machine, it would cost way more time and it would cost way more money. So as you can see here, we spent around 50 euros from also the mold and the propeller cost, which is carbon fiber and epoxy. And for a milling aluminum propeller, that would be around 400 euros. So we save a lot in here. So quickly to testing and results. We can see a few props we made here. We can actually see the blue line, which is our aluminium prop, which is milled in 2018. That's the first propeller we used. And you can see 2 different carbon fiber propellers which we made last year, the orange and the green one. So the orange one is actually a little higher in usage, in power usage, but it also gets the top speed we wanted, which is around 32 kilometers an hour at 65,000 watts. And the orange line is a bit higher in power, so that was a little bit less efficient. So yeah, the main result here is that we can get a propeller for 50 euros. We can make it ourselves in-house, and it takes about 48 hours with the hardening of the epoxy in it. So, planned improvements for next year. What we would like to do is get the boat on hydrofoils, which is our main goal. And also for the propeller, what we want to do is to make contra-rotating propellers. And yeah, that's about it. So, thank you all. Some questions?
Yes, we have one question. What was the fire today?
That was coming, yes, okay. So we had a little bit of a problem with our charge distribution. We have a small charging cable running from back to forth, which was laying, which came loose from the deck and was laying on the floor of the boat, and there came water in the boat. So, yeah, it was actually a short from the battery charge, and which went into burning, resulted into burning in the charge distribution. Yeah, it's very unfortunate, but we already managed to fix it. So, yeah, we hope to be out on the water tomorrow.
That was my next question. If someone has another question? The dinner tonight is good. Have a good night. Thanks to all of you. Thank you and congratulations.
Thank you.